find the local maximum and local minimum values of the function, and the function is given x squared times e raised to x. Okay, so to find local maximum or minimum values, first we need to look at the domain and find its critical numbers. So domain of this function is, so x squared times ex, this is defined everywhere, and so is x squared, so all real numbers. Next we find its derivative. So we got a product of two functions, two factors, so pretty much a product rule to find the derivative of this product. So derivative of x squared from the product rule, so derivative of first factor leaves second alone, plus derivative of second factor times leave first alone. Now we set this derivative 0. Okay, that means this expression equals 0. Look at in these two terms, we can factor x and ex out. That leaves 2 in the first term plus ex out, x squared, 1 copy, 1 left, equals 0. So we set the derivative 0, and I factored this derivative, which is this. So we got a product of three things 0. Note that exponential function is never 0. It never, if you graph this function, it never intersects x-axis. So this is never 0. So either x equals 0 or 2 plus x equals 0. And from 2 plus x equals 0, we get x equals negative 2, right? Because 2 plus negative 2 is 0. And from here, x equals 0. So this is never 0. So the critical numbers are 0 and negative 2. Okay, so the local maximum and local minimum values can exist, okay, at 0 and 2. So we do the number line, the interval test or sign chart, 0 and negative 2. So 0 somewhere here and negative 2 maybe here, and domain is all real numbers. So we need to test 3 intervals here: negative infinity through negative 2, negative 2 to 0, and 0 to infinity. So pick a representative from each interval, maybe negative 3 here, negative 1, 1, and plug these derivatives into the, plug these representatives into the derivative, which is here. So we're going to plug into derivative and find the sign of derivative, whether this is positive or negative. Okay, so negative 3, so our derivative is here. In fact, we factored, and this is here, so this was, in fact, we could have factored, we factor here x ex, okay, and 2 plus x. Okay, let's plug in negative 3 here. So this is negative 3, this is never negative, so we don't have to even take care of this part. Negative 3, 2 plus negative 3, 2 plus negative 3 is negative 1, negative 1, and this is negative 3, so negative, negative, positive. So the derivative is positive here. That means on this interval the function is increasing. And let's look at negative 1. So exponential function has no effect because this is always positive. Here is negative 1, 2 plus negative 1 is positive 1, and this will be negative then. So on this interval the derivative is negative, so the function is decreasing. And at positive 1, okay, when we go for positive 1, this is positive, 2 plus 1 is also positive, so everything positive. So the function is increasing. Look at here, at negative 2, on the left of negative 2, the function is increasing, then decreasing. So local max here, decreasing, and increasing means local minimum here. So local max at -2. And if you want to find the values, because the question wants you to find the values, this is the location for local maximum, and the local max value means we need to plug this in the original function, which is here. So x squared times ex. So -2 is squared, which is +4, e raised to -2, which is a decimal number. Okay, we don't have to go for decimals, just leave there. And local minimum at 0. Okay, and that local minimum value is, plug this in 0 into the original function again. Just go back to the original function, x is square ex, plug in there. So 0 means 0 is squared, 0 times e raised to 0, 1, so it's 0. So the minimum value is 0. Final.